Hi everyone, in this series of videos, I'll be making an automatic transfer switch controller, and I'll use the automatic transfer switch controller to illustrate the recommended standards for going about your final year project at Ashesi that involves electronics. I will first illustrate the importance of capstone projects and then show you how you can select a project for your capstone. I will then go through the Ashesi recommendations and the requirements that we expect from you at Ashesi whenever you are doing your final year project. I will then give you an overview of the sample project, which is the automatic transfer switch controller. And then after doing that, I will take you through the simulation of the circuit with Proteus. So in this part, I'll be showing you basically how to use Proteus. I will then go through how you can create the printed circuit board for the project using the Order Mill Pro CNC machine. After that, I'll show you how you can create your prototype in a factory in China called JLC PCB. I will then demonstrate how you can assemble your project, and this will be followed by testing of the project and programming the project. I'll run you through how you can do functional testing as well as system testing, as well as testing of your code. The Accreditation Board of Engineering and Technology, the institution in US that accredits all engineering programs, has 11 outcomes for every student coming out of any engineering program. And out of the 11 outcomes, 8 of them border around your capstone project. I'll take time to go through all those outcomes with you and highlight why your capstone is the most important thing that you need to do as part of your engineering education. A capstone project will enhance your ability to design a system or a component of a system to do a particular task. Your capstone is also supposed to help you learn how to function on a team of multi-majors or multidisciplines. Your capstone is a tool that can help you to understand professional and ethical responsibility. Your capstone presentation is going to help you to communicate effectively, and then it will also broaden the education that you need to understand the impact of engineering solutions in a global and a societal context. So when we ask you to find a problem in your surrounding and solve it as capstone, we want you to understand the impact of what you have learned in school and how you can apply it to your society. Your capstone project will also help you recognize the need for and be able to be a lifelong learner. We normally ask you to do a lot of research, and all those research towards a goal is something that can help you to become a lifelong learner. Your capstone is also a tool that is going to help you recognize the contemporary issues that we have currently in our society. The capstone finally is a tool that can help you to use the techniques, skills, and then the modern engineering tools necessary for you to practice engineering when you are out of school. All these criteria are from the ABET website. Now, how do I select my final year project according to ABET? Your final year project should emphasize design, experimentation, or hands-on skills. So all the hands-on skills that we focus on at Ashesi, you need to bring all of them to bear when you are doing your final year project. Your final year project is also an opportunity for you to exhibit your creativity, which means your final year project must look very nice and should involve a lot of creativity from you. Your final year project should not be something that you alone can do. It should be something that you have to do in a team, or you have to do with people who are in different courses other than the one you are studying. Now, the project should be complex enough so that every person in the team should be able to contribute up to 150 hours of class time and then 150 hours of outside class time to it, which means it must not be something simple like capacitors, resistors on a breadboard. Now, your project should be something that helps you to apply what you have previously learned in your coursework. So don't look far when you are looking at your capstone. Look at things that you have learned already in school and how you can apply them. Your capstone should follow all engineering standards in your local context. And there should be realistic constraints such as economic, environmental, sustainability, manufacturability, ethical, health and safety, as well as social and political constraints. Meaning you cannot do your project in a box. Your project has to be something that should follow the standards of where you are. Your project should have a schedule. Normally, it is recommended that you do your project within 8 months. That is the early part of the first year, first 4 months of the next year. Your project should also have concrete and measurable goals. I believe this criteria can help you to choose your projects. Let us now talk about the Ashesi recommendations. Your Ashesi project should look elegant, beautiful, and should be properly packaged. It should not be something on a breadboard with a lot of wires hanging around it. It should look very nice, beautiful. I'll elaborate a little bit on what I mean when I say it should be beautiful and elegant. It should be a project that you design and build within a specific budget. We usually give a budget of $50 for every capstone project at Ashesi. And most of the time, it is recommended that you build within that budget to enhance your skills in budget management. Now, even though your project is going to be a prototype, at Ashesi, we expect it to do exactly what you asked it to do. And your project must be mechanically robust. It shouldn't be something that when somebody carries it, it begins to fall apart. It should be something that when you are no longer in Ashesi, we can hold it and say this person did this on this and that day, and it can be there for generations to come and see. Now, your prototype should also be as close as possible to the real product that you want to be used. You shouldn't think that it is a final year project and you can just build it anyhow. It must be as close as real to things that we use in reality. Lastly, your engineering project must have every data that you get well documented. I'll throw some more light on that soon. So these are two different projects I want to use to illustrate how elegant and beautiful your project should look. This is a beautiful casing for a project that has terminal blocks that someone can connect wires to and then wire various sensors on a farm. So there's a PCB in this case, and then the terminals are exposed using terminal blocks, and the wires come out from here. Another one is a nicely laser cut casing for the project. You can see that everything has been well enclosed in the laser cut box, and only the LED is showing, and the container is well bolted in place. Now, your project must be built within a budget of the $50 that we recommend. And our goal is to make sure that you learn how to manage money when you are working on projects. Now, these are two other packaging skills that I have included in this slide. There's also another laser cut plexiglass case, and these are 3D printed cases, also with terminal blocks showing at the outside of it. And we can do all of this in Ashesi very easy. Now, your project should do what it has been designed to do. If you want your project to measure the height of somebody, you should be able to measure the height, and you shouldn't come and tell us that it is a prototype and because of that it only measures the height up to something. You should be able to measure the height of an actual person, all right? And if, for example, you encounter challenges and your project is not able to do what it is designed to do, you must make sure you make it do exactly what it is supposed to do before you leave school. Now, your project must be mechanically robust, which means if you take this project and you do anything to it, it should still be able to be the way it was designed to be. For that reason, we don't recommend your final year project on a breadboard. We also do not recommend using an Arduino board for your project. If you want to use a microcontroller board, you can take the microcontroller from the Arduino board and use it, but the main or other prototype boards are not allowed in your project. This is an example of a project that is recommended. The student is able to build a nice printed circuit board, connected his or her sensors to it, and is ready for packaging. Now, your project, even though it's a prototype, should be as real as possible. So if, for example, you are doing something that involves motors, make sure that you use the exact type of motor that is used in industry. Don't use the 12-volt motors that we have on campus that we use for teaching purposes. When you go to industry, the motors you are going to encounter there are going to be high voltage motors. So strive as much as possible to use the real industrial stuff which we have already on campus. Another one is students prefer to print gears and all those stuffs. When the actual gears are there and on the local market, try and get them instead of trying to make your own using prototyping materials. You must make sure that all the engineering data of your project is well documented. It is recommended that you make a website for your project and then document the various steps you have been taking over there. When you get to final year, you'll be allocated a server space on the Ashesi server for you to upload your work on. It is something that we do that helps you to learn webmaster skills, and we highly recommend you use the Ashesi server space to host your project information. Now, every software that you write for your project should be version controlled, and it is highly recommended that you don't only keep local copies on your laptop, but you keep a version controlled copy of your software on the internet. Now, if someone just comes to Ashesi and the person doesn't know anything about your project and the person reads your documentation, the person must be able to reproduce your project based on the documentation that you have provided. All CAD information or every simulation must be shown to your faculty who is supervising you, and all those simulations must be approved before you finish your project. Now, let me now talk about the sample project that I will be doing to illustrate how to go about your final year project. My client is a solar installation company located at Hachu in Accra. And the image below is the image of their electrical room. And then they have two contactors here, contactor A and then contactor B. Now they have two sources of power. The first one is the grid power. The second one is the solar power. And my goal is to be able to prioritize the solar over the grid whenever both solar and the grid are available. So I have been tasked to build a controller for these contactors and then turn on the contactors as per the preferences of my customer. Now, I will be using 3 different approaches to build this project. The first one, I will use a bare bone microcontroller. That's ATmega 328 or any microcontroller within its family. So the ATmega 328P is a microcontroller belonging to the Atmel family. I will then go with ARM Cortex and then build the same project with the ARM Cortex. And then after that, I'll be using ESP32 to design the same project for you to see. So when I use the ESP32 to build the same project, it becomes an IoT device. Now, this is an overview of the project that I'll be using to illustrate how to go about your final year project. At the heart of it is this microcontroller. And as I said earlier, I'll be using either ATmega 328 or ESP32 or either MKL25Z or STM32. The project has 4 LED indicators. The first one is the solar source LED. This one indicates that solar power is available. The second one is the grid source LED, and this indicates that the grid source is also available. The third one is to tell us whether the system is in manual mode or automatic mode. And then the next one is the automatic mode, which is also an LED to indicate that it is in what? Automatic mode. There will be 2 push buttons. The first one is to put the system into automatic mode, and the second one is to put our system into manual mode. Now, we are going to be having 2 relays. The first relay, which is the grid relay, will control the grid contactor, and then the second one, which is the solar relay, will control the solar contactor. Now, we are going to take the input of the grid using this into the microcontroller using this block, and then we are going to take the solar supply input into the microcontroller using this block. And then the yellow box here will be the power supply for everything on this block diagram. I will then have a debug interface and as well as an in-system programming interface for programming the microcontroller whilst it is on site.